video. Do your best to follow along, but you know it's always there for you if you need it. One thing that happened is the notes are really short, and then there's one homework problem I'm just going to do with you. It's the word problem. Some of you don't have that last page, so you'll just have to watch, and I will make copies for people that want me to get that to them. Okay, so I'll tell you about that at the end, but about half of you, I think, have the page that has number 16 on it, and some of you don't. So I'll explain it better when we get there, but I just want to give you that warning. I don't know, something happened with these packets. Some of the packets were not completed. So anyway, okay. So guys, look what we have here, a big old table of values, whole bunch of numbers, right? So you have this one row that's all your inputs, also known as x's, independent variables. Then you have f of x, g of x, and h of x. These are our outputs. Okay? And so we're just doing really what we did yesterday. You just want to be careful that you're, paying attention to what you're looking at, because there's a lot going on there, right? So let's start with g of 2 and plug it into f. Then whatever we get, we'll multiply it by 2. Then we'll simplify this one, add the numbers together. So g of 2. Don't forget g of x. 2 is your input, right? So you have to you always start on this top row, okay? So x is 2, then we would have to make sure we go to the correct function, which is g, and grab that y value. So g of 2 is -3, right? We always go right to left. Now we do f of -3. So you always start on that top row, your inputs. So x is -3. In the f function, the y value would be -4. So then we would do 2 times -4, and that would simplify down to -8. Okay? We're going to add it to whatever we get here. So again, always starting with that top row, because those are your inputs, h of 0, x of 0. So go to 0, go to the h function. H of 0 is what? 3. Then into the g function, 3. So starting on the top row, going down to the g function, g of 3 is 2. And so 3 times 2 is 6. Add them together, our answer would be -2. Stop me if you have a question, please. Starting with g of -2, input is -2, output of the g function is -1. H of -1 is 1.5. We'll multiply that by whatever we get over here. G of 2 would be -3. And f of -3 is -4. And when I put that in my calculator and multiplied it, I got -6. Anybody have a hard time with that? What did you say, Olivia? Oh, okay. Oh, it's okay. I didn't know if you were asking a question. Okay, we're not doing this one here. We're going to talk about some transformations, but I'm not making a graph. But this is something we didn't really do yesterday. We're still going to do a composition. We're going to put g of x into f of x and so on. But what we're going to do is describe what transformations. Guys, remember what transformations are. They're your translations, left, right, up, and down, reflections over x or y axis, dilations. We have vertical and horizontal. So those that keep resurfacing in all your classes, especially this one. All right, so I'm going to take g of x and plug it right in to f of x, right? So I'm going to put x minus 1 right there. And since it's got an operation being performed on it, I'm going to put it in parentheses. Now, yesterday, you had to simplify this. You had to square the binomial. Remember the little shortcut, or you could go off to the side and FOIL. But when we're talking about transformations, we want it in this form. We don't want to see it as x squared minus 2x plus 1, which is what it would be. We want to see the left, right, up, down type of language. So what we just did is we put x minus 1 into the x squared, okay? So this is what changed this, is how you have to think about it. So we had a parabola. What did putting that into the function do to the parabola? Where did it move it? Yeah. Remember in parentheses, that's your left or right translation specifically in this case. And so that, and it's always opposite. So that's a translation right 1 unit. Don't forget the stuff you already know, my darlings. Yep, vertical shift right 1. Yep, you can use the word shift. Not vertical, horizontal. Left or right is horizontal. Yeah. Yeah, but you could use the word horizontal. Okay, how about h of x into f of x? So now we're going to take this 2x and plug it into the same place. So that would be 2x in parentheses, because you're performing an operation on it. You're just squaring it, so you need to do it to everything. If that was just an x, you wouldn't need the parentheses, right? But since it's got something attached to it just like this, we want to show that all of it's squared. So you have to use parentheses, okay? This does not equal this. These are not the same thing, okay? So be careful with that. This is only squaring the 2. This is squaring everything. You want to square everything. Okay, so we just made this change to the parent function of x squared. What does a 2 inside the parentheses hanging out with x tell us about the transformation? No, it's okay. No. I was telling Zoe someone else, and I always feel so bad because dumb story, but when I was in high school, I was really into chorus. Like, chorus was my whole life. I was the president of our chorus in 10th grade. I sang the national anthem at all the football and basketball games. I sang at graduation. Like, singing was my life, okay? And my chorus teacher, I'll never forget, Miss Long, she would always be like, okay, let's, like, in class, and she'd be like, okay, everybody but Tracy. And it used to make me so sad when she would tell me I couldn't sing because I was so loud, like so exuberant about my singing. So it would be like, okay, let's do it again, this time without Tracy. And I always would take it like, it'll hurt my feelings. So whenever I say like, okay, like Zoe, let somebody else do it, I always feel bad. Like the little young 15, 16-year-old Tracy comes out in me and I'm like, oh, Miss Long didn't like me. Okay. And no, she loved me. But okay. So what did somebody besides Zoe tell me, what did doing this 2x to the x squared do to the graph? Those words, what do we say? Close. Let's use, instead of stretch and shrink, what's that other word? Dilation. And it is horizontal or vertical. We got to state that. Horizontal. If it's in the parentheses, it's horizontal. Horizontal dilation. I heard by factor of, that sounded good, but the next thing was not right. 1/2. Good, guys. Good. Remember, in the parentheses, it's wonky. Your opposite direction for left and right, and you have to flip your dilation. Okay? And you always want to say horizontal or vertical. I think it was you, Olivia, that said stretch or something. That's fine too, but instead, let's just use dilation. It covers both of them, and you don't have to worry about that. But you're not wrong. All right, last one. F of x into g of x. So now I'm putting this into this. So I have a line, right, that's down 1, y-intercept of -1, and I'm inserting an x squared. So that would just be x squared minus 1. Anybody want to tackle that one? What changed? What did that do to the x minus 1? I'll let Zoe answer if she knows it. No, it was already down 1. And nope. Okay, so not in parentheses, that's true. It is a down 1, okay? So that's not wrong, but that was already done. That graph was already there. X minus 1 was a line like this, okay? Something like this, right? That's what that was. That's already there. It's already been moved down. what we did was we changed the x, it used to be an x, right, which was linear, and we changed it to an x squared. It's so much, it's weird. Okay, so let me just tell you. Changed from a line to a what? Parabola. Right? We went from x to the first to x to the second. It went from this to this. So it's a weird transformation. I don't love that question. I don't love it, but no. G of x is what you're putting in changes the parent. This is the parent function. This is what you're starting with. Yeah. Just remember yesterday when we did the decomposing. All right, one more question. Last one. So guys, listen. I want to make this easy for you so you don't have to spend too much time on it. So I need you to just pay attention. F of x is graph for us, as is g of x. Okay? So you guys know what a graph is. It's just a whole bunch of ordered pairs. So what we're going to do in the first columns is just find the y values for each of these x values. So I color-coded them because I know it's easy to kind of get those, blur them together. So we're grabbing all the blue y values. So -4 when f of x. So x is -4, so is y. When x is -3, y is -2. -2, 0. Do we get the idea? Can I just give you the answers? You don't need to sit there and do all that. 2, 1, 0, 1, 2, 3. So hypothetically, we sat here and looked at this graph and just got all the y values of those x values of the blue f of x graph. Same thing with g of x. On the red graph at -4, the y value is 2. At -3, the y value is 1. And so on. I'm going to just call this -1.5. You'll see if you want to look at it. When you have to do a decimal, make it easy on yourself. It's roughly in between. 0.5 is the easiest to work with. We're not solving world problems here. It's not a big deal. If you call it -1.4 or something, whatever. Okay? So now, okay, that was easy, right? That's like pre-algebra level math. What h of x is right here. H of x is us doing f of g of x. So what we're going to do is take g of x, plug it into f of x. That will give us this new column. And you can use this table to help you. So so our first one would be -4. So you don't have to write this every time. Let's just write a few of them. F of g of, this would be the input for this row. Okay? And just do what you do. G of -4. So when x is -4 on the g function, my y is 2. It's exactly what we did on the page before. We just had to fill in the columns instead of them giving them to us, right? So g of -4 is 2. What is f of 2? Input is 2. On the f function would be 1. Let's do another one. F of g of, next input would be -3. And do what we've been doing, right to left. So g of -3, okay? When x is -3 on the g function, y is 1. Now I have to find f of 1. 1 is my input on the f function, that would be 0. G of -2. Input is -2 on the g function, the output would be 0. F of 0. 0 is your input on the f function, would be 1. So I want you guys to take a minute and finish that column, and then I will put the key up for you to check your answers. But I want to see you guys try this instead of me just giving you all the answers for free. Finish that column, y'all. Don't wait for me. In that situation, you'll have to go to the graph and see, okay? Since you don't have an input for it. So for negative 1.5, you go to the graph. I said just wait 1 second. So check your answers. If you listen, if you didn't get them right, or some of them right, and you want me to check them, I will in just a minute, because we're going to go to the homework, but I have to do one of them with you. So if you have a question here, remember to ask me in a few minutes, okay? Oh, you didn't finish writing them? Oh, sorry. So page 84, B12, 1 through 13, omit number 8, cross out number 8. Do it now so you don't have to do it. And we're going to do number 16 together. Some of you have number 16, some of you don't. If you have it, do it with me. If you don't, I'll get a number of how many people don't have it and who wants me to print it for them, and I will. I'll print it completed, like filled out for you so you have it. Good? So guys, often, as you've noticed, I might not do the word problems in the notes. I'll just do like word problems from the homework with you. Okay, so that's one of these times. So when I do this, you should be doing this with me. And I know some of you don't have the ability to write it down. This is not going to take a long time. I need you guys to pay attention though, okay? All right, because this could happen to you in real life. You could use this. This is real life application of math, okay? Your favorite restaurant is offering a 15% discount on their entree menu items. So that's a special they're having. You order an entree, you get 15% off. But guess what? You have a $5 coupon, which means you're going to take $5 off something. So we're going to write functions to model those two situations. And then we're going to see, does it matter if you do apply the coupon first and then take the percentage off, or the other way around? Does the order matter in this situation? So let's start by saying, okay, what do we not know? Because that's what we're going to call our variable. And of course, you can use any letter you want. But we don't know the price of the entree, okay? So let's just do these two. So we're going to have two different formulas. One where you do the discount, one where you do the coupon. The coupon's the easier one, right? I'm going to call it G of X. I'll call this one F of X. Again, you can choose whatever you want, okay? I'm pretty boring and I always use the same stuff, kind of. But you could have used H of X, whatever. Okay. If we're going to take the coupon out first, Guys, what do you do to the price of your entree? What's the math you do in your head to double check that the waitress gave you the right bill? Am I multiplying by 5? Subtract, right? Whatever the price is minus 5. Super simple, right? The discount, remember, you never plug a percent right in. 15% is the same as 0.15. Remember, you always have to move your decimal point 2 places to the left or divide your percent by 100 and it'll do it for you, okay? So you're only going to be paying out of 100% or total of 1, remember you do plus or minus. In this case, it's minus 0.5, right? You're not paying the full amount. You're taking 15% off. So you're actually only going to pay 85% of the entree. So when you're doing a percent of something, that's multiplication, right? So anytime you multiply a number by something less than 1, it's going to make the number smaller, okay? It's going to make it smaller. All right, so those are our two functions. Now, use composition of the two functions to model how much you pay for dinner entree if the cashier applies the discount first, okay? Discount is the f of x. I'm doing that first. That means it's on the inside. So that would be g of f of x. Think about that one more time. Let me say it. Discount first. Remember, we start here, go here. That's how I knew the order. Discount first. So I'm going to put all of this right here. 0.85x minus 5. Okay? So that's the formula we would use. Can't you see you doing this? Can you check out at a restaurant? All right, and then the other way first, doing the coupon first, would be f of g of x. We do this first. Okay, so I'm going to take all of that and put it right here. So since that's a binomial, I'm going to use parentheses so I can multiply these two together. And since x is not just a single number, I need parentheses, which means I will be doing the distributive property to finalize that. Okay? So 0.85x, and then in my calculator, 0.85 times negative 5 gives me 4.25. Okay? So I have my two equations now. Now some of you might, all of you, should be able to look at the pink and the purple and be able to say which one's a better deal for you. If it was a more complicated one or you couldn't see, make up a price of the entree. Like call it $10, and you could plug $10 in here and $10 in here and be able to answer this next question, which is how much more is an entree? How much more is an entree if the cashier applies the coupon first? So look at the comparison. In both of them, you're taking 85% off of it, and then this is minus $5. This one's minus $4.25. How much more are you going to have to pay if we do coupon first? 75 cents, right? That's the difference between 5 and 4.25. You don't even need to know the price of the entree. Okay? But if you couldn't tell what that is, make up a price and compare them. Just make sure x is the same for both of them. So order matters. All right? How many of you want me to give you a copy of this for your notebook? Okay, I'll make a bunch and just offer it to you guys tomorrow. Okay? Sorry about that if you didn't have it. Omit number 8. Oh my gosh. You guys, I forgot to tell you one more thing. So sorry. We don't have to do it, but let me just tell you. There was a part C here to graph the points. and I wasn't going to make you guys do it anyway in the notes, but in the homework I want you to, it's saying to graph, look, x, h of x. So these are your points. So you would have done like, guys, listen real quick, -4, 1, -3, 0, and so on. Okay, -2, 1, -1, 2. And so then you would have just connected those dots, etc. Okay, just plotting those points. So when you do the one in the homework, it's much shorter than this table. Go ahead and graph the x and the h of x. Okay. Right here. Mm-hmm. Okay.